Looking at is x cubed. So I went ahead and plugged in x cubed into y1. And what we want to do is figure out where is this graph concave up and concave down. Now this is a pretty basic graph, so you may be able to look at the original function and figure out where it's concave up and concave down, but sometimes it may be a little bit more difficult. You may not know exactly where it changes concavity. It looks like it's at 0, but what if it's like at 0.1? So we want a more precise way to do this. So the way we're going to do this is by having the calculator show us the second derivative graph. So we're going to use the graph of the second derivative to find out information about the original function. So first thing I'm going to need to do is I need the calculator to graph the first derivative before I can jump to the second derivative. So I'm going to go to math. Remember, number 8 is the derivative function. I want to take the derivative with respect to x, and I'm going to take the derivative of y1 for all values of x. So y2 is now going to give me the first derivative. So now if I take the derivative of the first derivative, I will get the second derivative. So again, number 8 is your derivative function. But this time, I'm going to tell it take the derivative of whatever's in y2. Again, for all values of x. Now, I only want to look at the second derivative graph, which is in y3. So I'm actually going to go ahead and turn off y2 and y1, so it's not super messy. Okay, I'm going to go ahead and hit graph. I'm just on a standard window, 10 by 10. And it will take a while because it does need to think about the first graph, the second graph, etc. So this is your second derivative graph. Now it looks like it crosses exactly at x equals 0, but let's go ahead and do that intersection just so we can make sure, because as we get into more complicated functions, they're not going to sometimes be at nice numbers. So I'm going to plug in 0 for y4, go back to the graph, and let's do that intersect feature, number 5, enter, 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 and it is exactly x equals 0 as we expected. Okay, so this is my second derivative graph. So I know that when the second derivative is negative, notice from negative infinity to 0, what's going to happen is that the original function is going to be concave down, and when the second derivative is positive, which is from 0 to infinity, the original graph will be concave up. So let's actually go ahead and put the original function on top as well and see. So notice on this portion of the graph is concave down. So that second derivative graph is below the x-axis. And then notice up here, the original function is concave up. So that second derivative is positive or above the x-axis. Another thing you can do is if you do not have a color calculator, in order to clearly see which one is which, you can make one of them bold. So I made y3 or the second derivative be bold so you can kind of tell. So this is the original, and then you'll see the bolded graph, which is the second derivative graph, come up there. There we go.